Hello everyone, myself Sai Prasad, a lecturer in Ahmedabad High School and the Junior College. Welcome to a series of the lectures of Intermediate Second Year Maths A. We started a discussion with our chapter Binomial Theorem. What did we learn? We learned different kinds of problems starting from the expansion, then terms, then we also did this kind of explanations, right? Fine. From today, we are going to learn 4 different form of expansions, that is not just 1 plus x whole power n. Instead of that, we'll have a fractional power, that is if it is power p by q. Before that, what is 1 plus x whole power? We know power n. What if 1 plus x, if it is 1 minus x, so how does it vary? That will be like nc0 minus nc1x plus nc2x square minus nc3 x power 3 and so on, isn't it? So by the same logic, we will have power p by q. I already told we will have 4 varieties, that is when both power and in the sign is positive, when one of them is negative and both are negative. So this will be like 1 plus p by 1 into x by q plus p into p minus q by 1 into 2 into x by q whole square and so on up to p minus q and so on up to p minus r minus 1th term of q by 1 to 3 and so on up to r into p x by q whole power r. Clear? Similarly, if 1 minus x whole power p by q is there, instead of plus we'll have alternative negative terms. Is it right? That's why we'll have minus 1 whole power r, where r is number of term. Clear? Fine. Based on this, we can also write 1 plus x whole power minus p by q. So if you just observe here, it will be like, since both are different signs, we'll have alternative negative signs. Clear? And one more thing, if you observe, here we'll have p into p minus q kind of term. Similarly, here we'll have p plus q and so on. Is it clear? So you can just observe like, if there is positive sign in between, you'll have all plus sign. If there is negative sign in between, you'll have alternative negative signs. Second thing, if you have positive power, we'll have p into p minus q. If you have negative power, we'll have p into p plus q and so on. Is it clear? And this is the main formula which we are going to use in most of the problems. That is 1 minus x whole power minus p by q is 1 plus p by 1 into x by q into p plus q by 1 into 2, that is nothing but 2 factorial, you can remember like that also, into x by q whole square, again p plus q and so on up to p plus r minus 1 into q by r factorial into x minus q whole power r. Is it clear? So based on this problems, we are going to prove most of the binomial theorems. Clear? Is it fine? Shall we do problems of those kind? Let's do. Look at the question here. He gave, find the set of values of x for which the binomial expansion are valid. When are they valid and how do we see the validity? First, see here. Remember, we always have the expansion of 1 plus x, right? Now let me do like, let us take 2 common, 2 plus 3x whole power minus 2 by 3 may say. Let us take 2 common, that will be like 1 plus 3x by 2 whole power minus 2 by 3, right? So how does it behave? 2 power minus 2 by 3 into 1 plus 3x by 2 whole power minus 2 by 3. What is this? 3x plus 2. It is valid only when the ratio is less than x is valid only if mod 3x by 2 is less than 1. Clear? So what do this mean? Mod x is less than 2 by 3. So it clearly tells that minus 2 by 3 is less than x less than 2 by 3. So clearly x lies between minus 2 by 3 to 2 by 3. Clear? So since it is less than, it is less than or equal to minus 2 by 2 to 2 by 3 to 2 by 3. Clear? What does this mean? It is valid for these set of values. Clear? Is that simple? Fine. Now, or else simply instead of this, let it be like that only, it will be more clear for you. Now see here, for this question, let me take 7 common. This will be 3x by 7 whole power minus 5, that is 7 power minus 5 into 1 plus 3x by 7 whole power minus 5. What is the term here? 3x by 7. Here x is valid if 3x by 7 is less than 1. So what does this mean? Mod x is less than 7 by 3. So obviously it lies between minus 7 by 3 and 7 by 3. Therefore, the values of x are minus 7 by 3 to 7 by 3. This is open bracket. Clear? Is it simple? This is not a closed bracket. Simply it is an open bracket. Clear? Is it okay? Shall we move on to the next problem? Let's do. Look at the question here. He is asking us to find the sum of infinite series. So, we know the infinite series 4. So, we have to compare and convert this infinite series into one among those 4. Okay? How? So, just see here. First, you can identify all positives. So, either it should be first or last. Right? That is fixed. Next, let s is equal to 1 plus 1 by 3 plus 1 into 3 by 3 into 6 plus 1, 3, 5 by 3, 6, 9 and so on. Right? Now, let me write that in such a way that it should be like 1 plus 1 into 1 by 3. Let me write it as 1 by 1. Why? You will get to know. Plus 1 into 1 plus 2 by, if I take 3 common here, I will get it as square. How many 3's do we have? 3 1's are, 3 2's are. Is it? Next, plus here 1 into 1 plus 2 into 1 plus, what is 5? 4. That is p plus q, p plus 2q, right? Here, if I take 3's common, I will get it as 1, 2, 3 into 1 by 3 whole cube. Right? 1, 3, 2, 3 and 3 3's we will have. Now, let us compare this with, see here, 1 plus p by 1 factorial into x by q plus, if you observe here, this will be like p into p plus q by 2 factorial into x by q whole square plus p into p plus q into p plus 2q divided by 3 factorial into x by q whole cube and so on. Is it right? Now just tell me, what is the value of p here? First of all, what kiska formula is this? 1 minus x whole power minus p by q. Is it right? Now just compare. 1 is same, p is fixed, done. X by q is 1 by 3. Now here p plus q is 1 plus 2. Here if we observe, p plus q is 3. I know what is p. So what is q here? 2. We got p, we got q. What about x here? X is equal to 2 by 3. Right? Now just tell me, what is the expansion now? S is nothing but 1 minus x whole power minus p by q. That is nothing but 1 minus 2 by 3 whole power minus 1 by 2. Is it right? So this is 3 minus 2, that is 1 by 2 power minus 1 by 2, that is nothing but 2 power 1 by 2. Yes or no? So simply it is s is equal to root 2. Is it right? Just see, 3 minus 2 is 1, 1 by, sorry, this is 3. So the answer is root 3. Clear? Is it simple? Once again, see here. We have to write this in the form of this formula. After that, we'll compare all the parameters and we'll write it as 1 minus x whole power minus q and simplify it. Clear? Is it okay? Shall we move on to the next problem? Let's do. Look at the next question here. He is asking us to find the sum of infinite series 3 by 4, 3 into 5 by 4 into 8, 3, 5, 7, 4, 8, 12. So how do we segregate? Remember, you will have some constant common difference in the numerator and common ratio in the denominator. You can observe. You will have 4 common term here. Here you will have, you have to add 2 for every term, right? So you can easily identify it. Now just see here, let S be 3 by 4, 3 into 5 by 4 into 8 plus 3, 5, 7 by 4, 8, 12 plus and so on. Clear? So now let us write it as 3 by 1 into 1 by 4. Is it okay? Next 3 into 5 by here 4 into 2. Can I write it as 1 into 2 into 1 by 4 square, and here 3, 5, 7 by 1, 2, 3 into 1 by 4 whole cube. Yes, so it's possible. So if we observe, we have a formula of 1 minus x whole power minus p by q as 1 plus p by 1 factorial into x by q plus p into p plus q by 2 factorial into x by q whole square and so on. Is it right? We have this term 3 by 1 factorial x by q we have this term also. So we don't have this term. So what shall we do? Let us add 1 on both sides. Add 1 on both sides. Right? So what do we get? S plus 1 is equal to 1 plus 3 by 1 factorial 1 by 4. 3 into 5 by 1 into 2 into 1 by 4 whole square. 3, 5, 7 by 1, 2, 3 into 1 by 4 whole cube and so on. Now what is the formula of this? This is 1 minus x whole power minus p by q. Before that we have to compare it. Isn't it? Now just tell me, what is there in the place of p? That is 3. Right? What is there in terms of x by q? 1 by 4. So x by q is 1 by 4. What is there in terms of p plus q? P plus q is 5. P plus q is 5. We know the value of p as 3. So the value of q will be 5 minus 3. The value of q is 2. P is 3. What about x now? X by 2 is 1 by 4. X is equal to 2 by 4. The value of x is 1 by 2. Isn't it? So what will be the value of s plus 1? S plus 1 will be 1 minus x whole power minus p by q. That is 1 minus 1 by 2 whole power minus p by q. Is it? This is s plus 1. So just tell me, 1 minus half is half whole power 3 by 2. S is equal to 2 power 3 by 2 minus 1. Right? What is 2 power 3 by 2? Simply 2 root 2, right? So the value of S is 2 root 2 minus 1. This is my answer. Clear? Same process. What did we do? We just compared, we simplified, and we took equalities of all those. Since 1 is left, we have added 1 on both sides. Then simplified. Then we compared it with the same formula, substituted. We got the value of S. Clear? Shall we move on to the next problem? Let's do. Look at the next question here. He gave t is equal to 4 by 5 plus 4 into 6 by 5 into 10, 4, 6, 8 by 5, 10, 15 and so on up to infinity. So that 90 equal to 16. So the first thing we have to do is we have to find the sum of infinite terms for this expansion. So how do we do? Just again, it is given as t is equal to 4 by 5, 4, 6 by 5, 10, 4, 6, 8 by 5, 10, 15 and so on up to infinity. Is it okay? Now we have to reduce it. How do we reduce? 4 by 1 into 1 by 5. Is it right? Here 4 into 6 by 1 into 2 into 1 by 5 whole square. Yes, here 4, 6, 8 by 5, 10, 15. 1, 2, 3 into 1 by 5 whole cube and so on up to infinity. Is it clear? Now again we have to compare it with our expansion. What is it? 1 minus x whole power minus p by q is 1 plus p by 1 factorial into x by q, p into p plus q by 2 factorial into x by q whole square and so on. Right? Again just check, here we have p by 1 factorial, that is 4 by 1, p into p plus q by 2 factorial whole square. Clear? So what is left? Again the same one is left, isn't it? So let me add 1 on both sides. That will be t plus 1 is equal to 1 plus 4 by 1 factorial 1 by 5, 4, 6 by 1, 2 into 1 by 5 whole square by 4, 6, 8 by 1, we can write it as 3 factorial into x by 1 by 5 whole cube and so on up to infinity. Right? Just compare. What is p? P is 4. What is x by q? X by q is 1 by 5. What is p plus q? Is 6. Done. Let us substitute 4 here. 4 plus q is 6. Q is 2. P is 4. Q is 2. What about this? X by 2 is equal to 1 by 5. X is equal to 2 by 5. We got the value of x, p, q. Now just substitute. Therefore, t plus 1 is equal to 1 minus x whole power minus p by q. That is 1 minus 2 by 5 whole power minus p by q minus p by q. Is it right? Fine. That is, this will be 5 minus 2, that is 3 by 5, and here it is minus 2. Yes, just check here. 5 minus 2 is 3 by 5, 2 ones are 2 twos are, which is minus 2. That is nothing but 5 by 3 whole square. Is it clear? What is that? This is t plus 1. What is t? 5 square is 25 by 9 minus 1. That is, LCM is 9, 25 minus 9 is, t is 16 by 9. We will get it as 9t is equal to 16. That is what he asked us to prove. Clear? What was the new thing here we found? All this thing we have added 1 on both sides in the previous sum also. Everything is fine, but from here we could prove that some relation which he gave. Clear? Fine. What all we learned today? We learned the 4 main expansions, that is 1 plus x whole power minus p by q, 1 minus x power minus p by q, 1 plus x power p by q, and 1 minus x power p by q. For these 4 expansions we have used only the 4th one, that is 1 minus x whole power minus p by q in the, more times. So in further problems also will this only this for most of the problems. Clear? But don't fix yourself that whatever you get in the question, that will be the same formula. Okay? It depends. Is it clear? Fine. This is for today. Let us meet in the next session with the more problems of binomial theorem. Thank you.